Hello, I'm Aaron, and I welcome you to Let's Learn. In this edition, we are going to be starting with raw number system, since we completed set in the last episode. Raw number system deals with the numbers and how numbers are being arranged. We are starting from natural numbers. When we talk about natural numbers are numbers that begin from 1 to infinity. So if we have a set of numbers that begins from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with my 3 dots, that shows it continues to infinity. This is a natural number. The next is a whole number. Whole numbers. When we talk about whole numbers, this is a group of numbers where it starts from 0. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to infinity, with my 3 dots to show it goes on and on. The difference between the natural number and that of the whole number is the 0. Whole number begins from 0, whilst a natural number begins from 1. Let's talk about integers. Integers are positive or negative whole numbers. Therefore, we can have positive whole numbers and negative whole numbers. So let's have positive whole numbers, which are integers, Integers. Example is 0, 1, 2, 3, to infinity. Whereas negative integers are -1, -2, -3, -4, -5 to infinity. Negative whole numbers begin from -1 and it increases with that order. -1 is the highest negative integer, and so as it goes, so as it decreases. Positive integer begins from 0, and as it goes higher, as it increases. So let's combine the positive and the negative integers, starting from -5. So we have 1, 2, 3 to show it goes on. -5, then down to -4, -3, -1, -2, -1, then move on to 0, 1, 2, 3, 4, and 5. With our 3 dots to show it goes on. Let's move on to rational numbers. Rational numbers are numbers of which we have an example as A over B. If you see any number that is in this form, it's a rational number, of which we have types of rational numbers. First one, we also call this as a fraction. This is called a fraction. So the first type of rational number we are going to be dealing with is a proper fraction. With a proper fraction, the numerator is always smaller than the denominator. If I talk about the numerator, it is the number or the figure up the bar, and the denominator is the figure beneath the bar. So if we have a proper fraction is a fraction of which the numerator is smaller than the denominator. So we have 1 over 2, we have 2 over 3 as an example, we also have 2 over 5 as another example. The next is an improper fraction. With an improper fraction, it's the opposite of a proper fraction. With this one, the numerator is bigger than the denominator. So we have an example as 10 over 3. We can have another one as 5 over 2 and 129 over 22. This is an improper fraction. We also have mixed fraction. Mixed fraction. A mixed fraction is the chain form of an improper fraction, whereas we are bringing in a whole number, a natural number. So we can have an example of a mixed fraction to be 7. We are changing an improper fraction into a mixed fraction, so you know how it looks like. So we have 7 over 5. Changing it into a mixed fraction, we get one whole number, 2 over 5. The reason being is 5 goes into 7 1. We have a remainder of 2, so you write the 1 as a whole number, the 2 as the numerator, and the 5 as the denominator. Another example is 25 over 8, an improper fraction. Changing it into a mixed fraction, we get 3 whole number, 1 over 8. 8 can go into 25 3 times, so we write the 3 as the natural number, and the remainder is the numerator. The denominator is the 8. The next is terminating decimals. When we talk about terminating decimals, it means changing decimal numbers into fractions. So we have an example to be 0.5. When we change 0.5, we get 5 over 10. The point moves behind the number, changing it to 5 over 10. We have another example to be 0.731. The number of rounds the point make determine the number of zeros behind the 1 beneath. So we have 1, 2, 3. So we are going to get 731 over 1000. The next is recurring numbers. So we have recurring. Decimals. When we talk about recurring decimals, there are decimals of which the numbers recur. It follows each other. For example, we have 3. So we can have a decimal like 0.333, and it's continuous, it never ends. So with this, we can change it to 0.3 with a dot on top, of which this is gained from 1 over 3. Another recurring number is 0.09, of which both the 9 and the 0 and the 9 are recurring. So when you solve this, that's 1 over 11, you are going to get 0.09090909, and it continues to infinity. Irrational numbers. When we talk about irrational numbers, these are numbers that do not have an end. For example, we have pi, which is 22 over 7. When this is divided, we get a figure like 3.4159265, and it goes on. So with this, we round them into different forms. So we can have 3.142, rounding it into the 3 decimal place. We can also round it to 4 decimal places and so on. We also have root 2, of which is also a rational number because when you divide it, it doesn't have an end. So we have something like 7.414213562, and it goes on. This brings us to the end of this section on raw number system. Thank you.